Are you tired of constantly struggling to find solution while coding, working late into the night and feeling frustrated despite numerous attempts? Many factors contribute to this, but one stands out as the biggest time waster in your coding journey. Can you guess what it is? Less understanding of the requirement? That's a valid point. While understanding the requirement is important, it may not be the primary challenge that most people face. Unit test? That's not quite it. Although unit test takes most time than actual development. Debugging? You are on the right track. Indeed, debugging has the potential to prolong the coding process and closely relate to our main culprit. Trial and error? Yes, my friend. This is without a doubt the most time consuming aspect of your coding journey. In this video, we will take a deep dive into the world of trial and error, exploring its inefficiency and the factors that contribute to it. We will also discuss proactive and reactive approaches and examine common scenarios where trial and error is commonly used. Welcome free minds, I am Sanjay, a technical manager based in UK. On this channel, we explore evidence-based strategies and tools that improve work-life balance, allowing you to prioritize your personal growth, achieve happier, healthier, and wealthier life. I am excited to have you here. Let's continue this journey together. On a typical day, software engineers engage in multiple rounds of trial and error. We commence by writing the code, by eventually encounter obstacles that promote us to seek solution elsewhere. We often find potential remedies on platforms like Stack Overflow and proceed to test them out, only to encounter errors or unintended behavior in the application. This process of searching and attempting continues for hours or even days until we successfully resolve the issue and progress. What is problematic about this process? We will delve into that shortly. I distinctly remember a particular day when we were attempting to call a third-party API from a front-end application from a Chrome browser. However, every time we made the call, we encountered a cross-origin error. My knowledge of cross-origin was particularly non-existent at that point. Despite days of trial and error, we were only able to make it work using curl from a server, which puzzled me at it worked differently than the browser. After 4 days of constant struggle, feeling frustrated and anxious, I dedicated an hour to learn the basics of cross-origin resource sharing, which is CORS. After realizing I was overwhelmed and not absorbing knowledge, I took a break for the day and got a good night's sleep. The next day, with renewed focus, it only took me 15 minutes to understand the concept and uncover the crucial line I had overlooked. It stated, due to security reasons, browsers restricts cross-origin calls. This basic knowledge transformed my perspective as I had been solely focused on making it work within the browser. Having gained a comprehensive understanding of the course, I not only find the solution to my problem but also implemented it in my code within another hour. Trial and error is not a bad process. It's actually a valuable method that fosters learning and discovery. Scientists frequently employ this method to uncover new solutions. It is similar to scientists conducting an experiment to enhance their understanding, and eventually the breakthrough moment occurs when they succeed. The key difference is software engineering use trial and error to complete the task, and scientists use it to gain deeper understanding. However, let's address the question first: how do we discover solutions through trial and error? The answer lies in building an understanding and navigating our way towards the solution. But where exactly does this understanding come into play? Surprisingly, we often fail to consciously prioritize its development. Returning to my story, after persisting in trial and error loop for 4 days without finding a solution, I made the decision to take a step back, and I realized that each attempt only led me back to square one. What I was missing? The answer becomes clear. I lacked a fundamental understanding of the subject. You see, after days of struggle, I unconsciously altered my strategy to address the actual issue. Introducing a new element to my trial and error process, it's not basic understanding. No, my friend, it's observation that helped bridge the gap between the problem and our comprehension. But have you observed? It appears that you are enjoying this content and gaining deeper understanding. Why not show some love by hitting the like button and subscribe to this channel? And remember to share it with your colleague as well, spreading the knowledge further. Let's delve into the common type of understanding that can minimize trial and error while solving the software problem. Firstly, it's crucial to grasp a clear understanding of the problem statement itself. Without clarity on what we are attempting to solve, valuable time is likely to be wasted. Secondly, we should strive to understand the programming language and library or tools we are working with. Having an understanding of how the language functions internally works enables us to navigate more effectively and avoid unnecessary trial and error. Lastly, it's beneficial to comprehend formula or general mathematical concepts that may be relevant to our coding tasks. Gaining familiarity with these three common types of understanding is crucial. When you observe during the trial and error process, it's become important to identify which type of understanding you may be lacking. There is also possibility the combination of this type of understanding you might be missing. Once you pinpoint it, the subsequent step become remarkably simple. But Sanjay, I understand your concerns, and it's true that acquiring a deep understanding of the programming language and mathematical concepts may take considerable time, possibly days or even months. You are right. But let's look at the solutions available for that without spending lots of time. I approach each problem in my life from two perspectives, proactive and reactive. The proactive angle involves developing the necessary skills and knowledge over time to handle various scenarios, while the reactive approach I involved using hacks and techniques to overcome obstacles when I get stuck. Understanding in any form requires time and experience to become proficient, allowing you to identify common pitfalls more effectively. Here are some steps to consider before starting a project. Prepare before starting. It's beneficial to explore the upcoming project or task beforehand. Understand the nature of the project, such as building an e-commerce website, and familiarize yourself with its features. Consider potential solutions and conduct quick proof of concept tests to understand common edge cases. Research programming language and relevant areas. Determine the programming language required for the project and conduct research to identify specific areas within that language you need to focus on. Assess if you need to learn a new database or understand a system design, and plan your daily learning accordingly. Identify mathematical calculation involved. For instance, if you need to display charts or work with D3JS, refresh your knowledge of geometry. If time calculations are necessary, review concepts related to your years, months, dates, hours, minutes, and various expectations. By following these steps, you will be ahead of your team and avoid unnecessary uncertainty and pressure, particularly if you lack prior experience with the tools and the domains. Take it slow, make consistent progress, and don't stress out too much. I have found this approach to be effective. I used to feel pressured and fearful when starting something new, fearing that I lacked knowledge and would appear foolish. However, I realized that achieving similar result with joy instead of fear can significantly reduce pain, struggle, enabling better progress. Embark curiosity in your learning journey. Enjoy the process and thrive. If you tend to be fearful, try reminding yourself in stressful situations that you have a choice between joy and fear. With continuous practice, you can gradually change the default setting of your brain. Read programming books. While there are numerous free online resources to help solve problems, building a deeper understanding often comes from reading technical books. These books take you through necessary steps in a coherent manner. I am not referring to competitive coding interview books, but rather programming books that cover the basics and provide deeper insights. Books on design pattern, database, and system design offer valuable knowledge. I confess that I have not read many coding books, and even for the few I have read, I may not have finished them entirely. However, I can confidently say that reading these books significantly enhance my understanding of the topic and expand my knowledge. Allocate fixed 1 hour learning time. I find it beneficial to set aside a dedicated 1 hour learning time to explore new things, especially topics of personal interest. Initially I scheduled this time during evenings or outside of the office hour. As I gained knowledge, some companies allowed dedicated learning hours and I leveraged that 1 hour time slot. Gradually, as you strive to work more efficiently, you can reduce your working hours, filling up more time for personal growth and development. While you may have prior knowledge about most projects, there are instances where projects start from scratch, requiring you to make decisions on programming languages or system designs. In such cases, you need to learn a new language while working on that project. This is when the reactive approach or hacks come into play, a just-in-time solution for your problem. Allocate time for just-in-time information, which is I call JITI. When you encounter a problem stemming from a lack of understanding, it's crucial to set aside dedicated time slots of 15 minutes, 30 minutes or 1 hour based on your intuition of how long it will take to grasp the concept. During this session, engage in reading articles, exploring documentation and watching relevant YouTube videos. Approach this session with curiosity, focusing on learning rather than solely searching for the specific solution you need. Surprisingly, spending just 15 minutes studying can often resolve 80% of your challenges. Afterward, investing another 15 minutes in attempting to fix the issue, you will likely find the solution. Now imagine a scenario where the solution remains elusive despite these efforts. As I understand the urgency to resolve the problem, I encourage you to get up and stretch, then return to repeat the process. This can be beneficial. The key is to focus on one thing at a time, either understanding or finding the solution. We often mix the two, leading to constant context switching that hinder progress. I realized that initially this approach may be challenging, as all new things tends to be. However, with consistent reminder of these principles, you will gradually improve. I will provide you a poster that you can place near your workplace, serving a constant reminder. By doing so, you will train your mind to optimize energy and allow it to subconsciously work on finding the solution while minimizing the context switching between learning and problem solving. One common scenario is encountering error messages from library or programming languages. We often succumb to the temptation of performing a quick Google search, hoping for a instant fix. Sometimes it works like magic, while other times we left perplexed. When you are new to the programming language or a junior engineer, it's highly likely that you will resort to trial and error without fully grasping the fundamental concept. However, it is crucial to strive to avoid this approach, instead maintaining an open mind, constantly seeking new information and knowledge. Don't confine yourself to a limited pool of knowledge. Again, a frog in a pond. Allow me to share my experience with implementing course. I was convinced that I was doing everything correctly and making no mistake, receptive to new insight and information. However, I failed to consider the possibility of unknown factors. Therefore, it's vital always to remain receptive to new insights and information, preventing unnecessary stress and setbacks. Another scenario arises when we encounter challenges in coding specific functionalities. It could involve implementing a complex formula or understanding a intricate mathematics. The immediate temptation is to search for a generic solution online which may not align with our precise requirement. Let me share the story of my colleague Sital, name has been changed for anonymity, who struggled for days until she took a step back and dedicated time to study geometry. The result, she successfully solved the problem in just 15 minutes. Let's not forget the troublemaker regular expression or regex. They can be quite daunting and often lead us down to a trial and error rabbit hole. By embarking a more structured and knowledgeable approach, we can reap several benefits. We will save valuable time, experience, fewer frustration, and ultimately become more productive and satisfied developer. Remember, understanding the problem, the language or library, and any relevant formula or mathematics is key to your success. Well, what if I told you there is a powerful habit that can help you work less and achieve more? Well, you are in luck. Check out the popular video on this screen right now where I delve into these habits and provide valuable insights. Get ready to optimize your productivity and make the most of your time. Let's embark a more efficient and informed approach, making our development experience more enjoyable, rewarding. Until next time, happy coding. See you in the next video.